Hello, today we're going to talk about literal equations. That's kind of a funny word, literal, but what we are going to see is that after we've learned how to solve equations, like solving for x or y or whatever letter they've given us, we can apply those same processes, like moving things from one side to the other, with an equation that has nothing but letters in it, variables. So we just want to be able to see that we can rearrange an equation even though there's not a set number we're looking for, but we can apply those same processes. So let's take a look at a few examples that you'll see these kinds of things in your lesson. So the first one is x plus a equals yb. And they're going to tell us what to solve for. So we're going to solve for y. So what that means is we want it to solve or say y equals. So when we're done, we want y to be all by itself. So we treat everything else like it's a constant. Y is our variable in this case. So when we look at this, we look at this side and we say, well, y is almost by itself, but it has a b next to it. And we have to remember that if two things are next to each other, that means that they are multiplied. So when they are multiplied, the way we undo multiplication is we divide. So we're going to divide both sides by b. And on this side, those cross out. We're left with y. And on this side, we notice that none of these things are like terms, so we can't squish them together. So we just kind of stack them where they are. So y equals x plus a divided by b, and that would be our answer. All right, let's look at another example. We're going to look at a, b plus c equals d, and we're going to solve for a. Right, solve on there. Solve for a. So right now it's solved for d technically because d is all by itself, but we want to solve for a. So that means we have to get rid of the b and the c. So again, we rely back on our skills for solving and we pretend that the b and the c and the d are constants. So the first thing is I'd have to get rid of the c. It's kind of the dangling one. So it's added. So again, we do the opposite of what's there. We're going to subtract c from both sides. We're going to have a, b, c minus c is 0. And over here, we're going to have d minus c. Again, we just kind of write them as they are. The next step is, because we're not done, a is not all by itself. We have a, b. And again, a and x, or two things next to each other are multiplied. So to undo that, we divide. And divide both sides by b. So we get a equals d minus c divided by b. And now we've solved for a because a is all by itself on one side of the equal sign. So we're good to go. Let's look at another example. 3abc plus b equals 5. And we want to solve for c. Okay, so got a lot of things going on, but again, we rely back on our cool skills that we have and start solving. So 3 ABCs all squished together. We have this plus b hanging out there, so we're going to go ahead and subtract b from both sides. So now we have 3ABC, b minus b is 0, and we have 5 minus b on the right side. All right, so now we have 3ABC all squished together. They are all multiplied. So in this case, if we want to get c by itself, because these are all the same process, they are all multiplied, we can actually divide them all together. So we're going to divide the entire side by 3AB. And what happens is we see that 3 divided by 3 is 1, a divided by a is 1, B divided by B is 1, so we have C left on the left side. And again, on the right side, we just keep stacking it up. So we have 5 minus B divided by 3AB. And then there we go. So this whole thing would be our answer. Okay. All right, one more example for us. It says, Mary wants to fill a cylinder vase. So I'm going to kind of paraphrase. A cylinder vase. And at the flower store, they told her the vase should be filled 2/3 for the flowers to last the longest. So we want to fill it 2/3 so we can keep the flowers nice and pretty. Her cylindrical vase has a radius of 3 inches. All right, a radius of 3 inches. All right, and it says a height of 8 inches. How much water should be in the cylinder? How much do we fill the cylinder with? Okay, so what we want to do here is we can always draw a picture if that helps. So a cylindrical vase means we're going to have something like this. And it's going to have, like we said, a radius. So we're going to create a radius of 3 inches. And then a height of 8 inches. Okay. So in this aspect, what do we need? What don't we have in this case in order to fill it? Because we also have this weird fraction that we have to deal with, right? 2/3. So what happens is we have to figure out how much does this cylinder vase hold. So in order for a cylindrical vase to hold anything, we realize it's a 3-dimensional shape, and so we have to find the volume. So we find the volume, and we need to know how do we find the volume of a cylinder. And so that's pi r squared h. So pi, remember, is a constant number, 3.14 to shorten it. R stands for radius and h stands for height. So if we plug that into here, so we're going to have v equals pi times 3 squared times 8. Now remember our order of operations. So 3 squared is going to be 9. So now we have 9 times 8 times pi. So that means we have 72 pi. And again, we have to probably get a calculator out in order to figure out what that is to be exact. So 3.14 times 72 gives us 226.08. So inches cubed. Make sure we use our units. So that's how much the vase would hold if it was full, but we wanted to fill it 2/3 of the way. So we only want it to be about here. So in order for us to do that, what do we have to do? Well, we now know how much it holds in total. Now what we do is we figure out how much 2/3 of that is. So basically what we have to do is find 2/3 of 226.08. Now we can do this a couple of different ways. So let me do some erasing here so we have some more room on our page. So filling it 2/3 full means we need to do some math here. All right. So remember, fractions are written like this, And if I'm multiplying it by something, the other thing can be written like a fraction by putting it over 1. And the way that we multiply fractions is straight across. So we have 2 times 226.08. And on the bottom we have 3 times 1. Okay, so going to our handy dandy calculator again, 226.08 times 2 gives us 452.16. And I didn't erase enough, so let me do that real quick. All right, so now we have 452.16, and 3 times 1 is 3. And now we divide that. So 452.16 divided by 3 gives us 150.72 inches cubed. So this is how much water we want to fill that vase with. That's how much water will be in there so that we can keep our flowers nice and pretty the longest. So that's it for this lesson. These are definitely examples from that lesson. So if you have questions, be sure to ask your teacher. Thanks. Have a great day.